Hello and welcome everyone. My name is Peter Robinson and this is the Ethereum Engineering Group Meetup. So today I've got Mark and I've got Ryan and we're going to talk about how we make sure contracts are secure at Immutable and the big long process that we go through. So hopefully the yeah, all right, audio is working. Cool. Before we dive in, Mark, do you want to introduce yourself?
Sure. I'm Mark. I look after the security team here at Immutable and work really closely with Ryan, who I'll hand over to now.
Yep. My name is Ryan, and I'm a security engineer here in Immutable, and I work very closely with Mark.
Yeah. Okay. And I'm Peter, and I'm head of blockchain research. Okay, let's share my slides. All right, here we go. Yeah, so let's do this talk. And yeah, so before I dive in, I thought I'd give a quick 30 seconds on what Immutable is, because some people have asked me, so what is Immutable? And so we're a world-leading Web3 gaming platform. So you can imagine you've got computer games of a huge variety. Apparently we've got 150 on the platform already. So we've got a StarkX and we've got a EVM-based platform. And so I'm personally very focused on the EVM-based platform, which we're in the midst of launching. And so you can think of the idea is you've got these games, they can use our wallet, which is a Web3 wallet, which really aims to not get in the way of actually doing things. So it's yeah, a great way of offering great security, but great usability. And we've got some off-chain services, and they work with validiums, and which, you know, essentially blockchains that are tethered to Ethereum. At the moment, the actual Validium part is not quite there yet, so it's just independent blockchain. We operate a whole heap of contracts on the chains, and we're partnering with Polygon. And so what all this gives the people in the games is true ownership of their in-game assets, but it's more than just NFTs. So it's a whole platform and system. And I think that's a pretty good description. I don't know, Mark, Ryan, is there anything else that we should add in our quick 30-second on Immutable?
Just to say that we think that one of the ways that mainstream folks are going to come to Web3 is through gaming. It's sort of an industry that's really open to using this kind of technology, and so that's why we're excited to be a part of it.
Cool. All right. So I'm going to give an overview of the process, talk a bit about the actual process in detail, hand over to Ryan, who will do a bit on that as well. And then Mark is going to talk about operational programs, and then I'm going to talk about the development when you're actually having an active attack and required features. So let's go through the process. So we've got the process takes you from essentially concept to having it online deployed and operating. And so what we've thought is, like, contracts have got different risks. And so some contracts may be lower risk and some are higher. And so they've got different paths through the overall flow diagram, if you will. And so different requirements. And so, you know, we've classified high risk to mean that it's going to have a mega impact. So say if that the wallet contracts, which are used with Passport, or say the bridge contracts, or anything that's related to the actual operation of the rollup, if any of them are, are broken, then that's a really big issue. So that's deemed high risk as well. If with the DEX or the Seaport, if there's any substantive changes to them, then they're key infrastructure, so that's pretty important too. Medium risk is if you have a substantive change to an application contract, or if you've got, say, just a minor change to one of these ones, the infrastructure contracts. And then low risk is just a minor change to an application contract. And so trying to split up and not require the full process for absolutely every single change of code. We've also got a registry, and at the moment it's just a spreadsheet, nice and simple, and it lists every single contract that we are building, that we're using, that we're deploying, and it gives us an understanding of what's in the system, what's out there. And obviously we've got, lots of contracts, we've got lots of contract audits happening, and they need planning to try and, make sure that you're, batching up and saying, all right, these contracts are going to be ready at the same time. So maybe they can go or be audited at once. And that helps with costs as well. And as well, it captures in one place a whole stack of information, which is really key to being able to respond to vulnerabilities. So it's used for vulnerability response. And so it contains a whole stack of information, from basic information about the contract. Who should we contact within the team to talk about it? Was it internally developed? Was it externally developed? Large changes, small changes to it? Where is it in our readiness process? Are we deeming it high risk or low risk, medium? And if we've forked it into the code, is there an upstream repo? And, let's have a look at that repo and have information about audits that may have been done for the upstream repo. We have links to the design documentation, the source code, test code, CI loop, everything. And obviously, there might be audits that we're having, so links to that, contact details for who's done the audit, and deployment information. So what the address is, and say if there are admin roles, what those admin roles are, and what are the addresses that have those roles, so that it's all there in one place, so that then if there's an attack, we can quickly say, well, who knows all about that contract? Where's the design? And let's just get into it. So that's a brief overview. Does anyone have questions about just the whole thing from a very high level? Cool. All right, so the design process, so we get people to write up a design. So we have a requirements, and then we have a design, and the design then, restates the engineering understanding of those requirements, and maybe has some more detailed engineering requirements, and talks about the relationship, the architecture, if you will, between that component and those around it, and talks about the main interfaces going into the contract. And the idea is to communicate with stakeholders what you're planning to do. And also writing a design really helps you reflect on what is in the what you're trying to build, and maybe you come up with some realizations that you might not otherwise have had. It should be a lightweight document. We're not aiming to have like a 500-page document or anything. It's something that you can put together reasonably quickly. People can read and review and comprehend simply. We also write tests and code at the same time. And also create a test plan as well, and really try and work the coding and the testing all together. And writing code, obviously you might come up with a test plan, which obviously influences what tests you're going to need to write. And then maybe as you're writing code, you'll realize that there is more capability which needs more analysis. So we aim to do the coding and testing in parallel. We use a static code analysis tool called Slither to try and help find issues. We use Linter to try and make sure we've got a common code style. We use fuzz testing for high-risk changes. And for upgrades, so as well as the traditional standalone tests, we also use the ability to do forking of on-chain data. So in other words, you've got the existing contract and you can fork it along with its data and then perform the upgrade and run the tests on the upgrade just to make sure that it's actually going to work when you do the upgrade. Currently, we prefer to use Forge as our tool, but these things change over time. And, we've got some test systems that are written in both Hardhat and Forge. And I'm sure there's some truffle testing out there somewhere as well. So it's quite a variety. So we write test plans, and the test plans are, again, not 500-page documents. They're something really simple where you're just a markdown file where it's saying, well, here is the test name, the name of the test, and here's what it's going to do. And, is it happy case, sad case? And if not all the tests have been implemented, has it been implemented yet? And so the idea is to try and get people to, again, reflect on the design, reflect on the tests that could be done, and then list out everything that could be done, and then make a conscious decision about which tests are going to be implemented. And so, it might take an hour or two to list out all the tests, whereas actually implementing all those tests might take several weeks. And so it allows you to, really work out what's important and what's not important. Threat modeling is super critical for preparing for audits. So having a threat model is a great thing because it gets you to list out the architecture, the perceived attackers, so who you think is going to be attacking your system. What are the attack surfaces? So what are the interfaces into the system, into your architecture, into your contract that an attacker could use and could be vulnerable, possibly? And so what are the possible attacks then, and how are they mitigated? And so trying to work from architecture, surfaces, attackers, and then the actual attacks and how you're stopping those attacks based on your architecture. And so you could well do that threat model and go, oh, we've got a problem. And what a great time to find the problem before you give it to the auditors, because and before it's deployed. So that can then obviously feed back into testing and test planning. The big thing about threat modeling is, and having a threat model document, is that it allows auditors to have a look at the the design and really see the well thought out thinking. And they might think of a new attacker or a new attack surface that you haven't thought of. And so it really helps them to quickly get up to speed on your project. So having a threat model will decrease the cost of an audit. Okay, internal audits. I'm going to pass it over to Ryan.
Yep. Thanks, Peter. We have actually put in a lot of thoughts in internal audits. And like what Peter mentioned, when it comes to threat modeling, the outcome of the threat modeling will definitely help to improve the quality of the audits when we hire an external auditor. And in a way, we try to do that in internal audits as well. So when the team or the contract owner have completed their development in contract development, they'll basically pass it to us. And we have two different groups to assess and also evaluate the contract. There will be the council, which is a internal and engineer focused team that will evaluate the contract, and also it will be Peter with a product security, and will basically try to rate the risks of the smart contract. And one of the things that we try to do is to apart from going through the usual manual and using automated tool to try to highlight all the issues that we have potentially on the contract, we also try to use the threat model to figure out what potential security concerns we have in the smart contract. And this can act as a treasure map when we decided to hire an external auditor, or even when we run a bug bounty, because smart contract can be complicated. And in our case, we do see that a lot of smart contracts has deep integration with the Web2 component, which is typically not being assessed. So from our point of view, we could use a bird's eye view to kind of provide a little bit more context on the Web2 component or the integration layer that can also that should also be assessed by the auditor. Yeah, I think over time we hope to improve our internal security audit capability. And we wanted to make sure that our teams feel that their innovation is they can innovate at a lower cost, and we don't want them to feel that audit cost is always a thing that they have concern with whenever they develop a new contract. But this doesn't mean that we will not hire external auditor in the future, because social consensus is also important. Yeah, Peter, if you may go to the next slide. So to prepare an internal audit, this is also somewhat similar to an external audit. So we have a list of questions. So this should be quite similar to what you typically would ask, what an external auditor would typically ask. But one thing that we have that is different from the usual external audit questions is how are keys being generated and being managed. I think these are usually the behind the scene, and external auditors are they probably focus a little bit more on the contract, but for us, we wanted to understand how are the keys being generated. Is the key being generated according to the best practices that we want? Because frankly speaking, anybody can generate their key, and anybody can store the key in whichever way they want. So this is one of the questions that we try to point out. And on the next slide, once we determine the risk rating of the smart contract, we actually have a small table on the bottom right corner, where we will rate whether if it's high risk, medium risk, or low risk, according to the criteria that was set by Peter and the team. And we also will evaluate auditors based on specific criteria on how many audits have they done. Are they on REC leaderboard? What's the reputation, their availability, and also methodology, and how much money are they charging? Yes, because obviously cost is important. With the risk rating and the complexity level of the smart contract, we will also consider whether if there is any availability from the auditors, and with that we will pick auditors from our premium tier or reputable tier, which is two different tier of auditors. And going forward, I think similar to internal audits, the more information that we can provide to the external auditor, the better that they can perform. So ideally we are like a sparring partner to the external auditor and try to furnish them as much information as we can. And because external auditors, they have to work on a specific hash ID, and they will usually audit on specific version of the smart contract. So this is something that we typically have to manage the contract owners to make sure that there will be no changes, and there will be a clear cutoff point. As usual during the audit, we'll have a work group from the engineering team that can help to clarify certain things that the auditors might bring up, and we also would use Slack or Telegram or anything that we can facilitate communication. We find good success to have a weekly call with the auditors, so that apart from brainstorming certain test cases that they might not think of, they can also highlight some of their concerns, and the engineering team can furnish them with more information. And once the audit has been completed, it's always helpful to keep a communication channel. So in the case of there is suspected attack, maybe the auditors can jump in and help to advise. Yeah, I think in audits, if there is issue that's been found, we will typically make changes, and we will need to have tests for the changes as well. So hacking contests is something that we are trying to look at recently. And the general process is you basically have a smart contract that you wanted to sponsor. It's similar to bug bounty program, where the audit is being open to public, but it has a strict time frame that's being set by the sponsor, which in our case is us. It can typically last from a few days to weeks. And you definitely need to have all your contracts and associated material or assets public. And our thought process is integration test versus unit test. In the typical external audit, usually we are bounded by a specific time frame. So there is the amount of things that they look at, it's correlated to cost. So when there is a budgeting concern, we might want them to look at specific assets. But in the case of hacking contests, because this is crowdsourced, and we usually will approach it like an integration test, where we will include Web2 components or components that are not typically being audited by external auditor. So it's a more overview audit. We also think that this is a good on-ramp prior to a public bug bounty program. In most of the Web3 specific bug bounty program, they actually don't include triage services. So, and they have the SLA on how long do the security team have to respond, whether if this bug is legitimate and the impact. Given the pressure, I think a lot of teams might not be able to triage it correctly, because some bugs can be quite obscure, and it will take time for the engineering team to understand as well. But in some hacking contests like Code or Arena, they actually crowdsource their judges as well, which is the triaging services, so you can have the confidence that all bugs are being triaged and they are all legitimate. And Code Arena as well, they have a very interesting initiative, which is bot race, where they will use automation tool to try to find all the findings that can be found by automated tools, and they would encourage researcher to find unique findings, which I think it's a pretty nice proposition. I think that's about it. Yeah, I think deploying to test network and main network, I think one thing personally, I came from the Web2 world, and in Web2 with cloud computing, anybody can essentially deploy stuff onto the cloud. I think this is no different compared to Web3. As long as you have a legitimate access to blockchain, you would be able to publish your contract. So this is something that we are trying to control, where if you wanted to publish your contract onto the mainnet, it has to go through us, and there will be an immutable deployer account so that it's verified. And on top of that, we would do additional verifier using the ENS. And yeah, the private key for that deployer account obviously is extremely important, and they'll be highly controlled. And Mark will be going into details on that. That's about it. I will pass it back to Peter.
Yeah.
On this.
Thank you. Yeah. And so, yeah, so when you're deploying a contract, on the in the block explorers, you can see whether a contract's got its code associated with it, and so it's verified code. And so that's actually really important for a few different reasons. One is to allow users to understand what the code is at that address, and it improves their confidence. But it allows you to check that the right version of code's been deployed. And that might sound a little crazy, but I know, having worked in an organization when there was an actual attack and we needed to deploy a contract, by mistake, the old version, which was vulnerable, was deployed, and the thought was, oh yeah, that's the right version, it's all good, we're ready to upgrade to that version and change all the services to that version. And it was only when we went to verify on the block explorer that we said, well, that's not verifying, we can't get it to verify. And so then it was a matter of verifying the old version and saying, oh, that's still the old version of code that we've just deployed. And so, especially in times of stress, I would strongly encourage not skipping this step, because it will give you confidence that you've actually deployed the right thing. And so the process does depend on the block explorer, but generally, you're going to have a contract address. You find out the exact compilation settings that you've used. So what Solidity version and what options you've used. And then you need to flatten the file. So that means essentially in the one.sol file, having all the different contracts that you need. and then you run the verification tool, and it essentially compiles the code and sees if the bytecode that it generates based on that version of the compiler and with those options matches what's been deployed. And if so, then it says verified and you're all good. So there's the link down the bottom there is to the cross-chain risk framework, and that's got a lot more information about how to do this and how to do it for a variety of chains. And so once you've verified the code, you're ready to go. And so you operationalize your code. And how you do that is obviously dependent on your system, but often you've got off-chain components and they point to certain addresses of certain contracts. So maybe you need to update those off-chain components. Maybe you've got a transparent upgrade proxy, and so it's time to switch to the new implementation. So whatever the way you do it, then you're at the final point. And so are there any questions about the overall process that we use for going from concept to a deployed contract? Mark, go ahead.
Maybe I should have asked the question earlier. In the kind of risks and requirements, you talked about changes. Is that like a player losing the magic sword, or is that like a smart contract upgrade, or do you even have smart contract upgrades? What kind of changes are you talking about in the risks?
I'll just go back a few slides. So we're
Sorry, I should have asked earlier.
Oh, hold it. This was how risky it was and whether it was a major change or not.
Yeah, these are kind of your requirements for the, I mean, when you're going to do an audit, you want to know what properties you're trying to ensure are being supported. And I just don't know what you mean by changes.
Yeah, they were code contract changes. So that was, like, have you changed a line of code here or there, or is it something more? That was, yeah. That's
okay. So you don't mean kind of misuse of the code that causes harm to users. That's kind of not the security objective.
Well, when you're doing these audits, you are worried about. So I guess if you thought that the code, if it was misused, could do something really bad, then that would be high risk. And I guess, say, for instance, if you think of bridges, that's why they're in the high risk category, because if you're able to misuse a bridge, then the impact of that is really high potentially. Yeah.
Okay. Second question, if I may jump in before David, is I'm not quite sure still if you're doing a kind of just a software audit or a kind of system security audit, because I thought mostly you talked about software and code, but you've also mentioned key management and also the off-chain components. And so it's kind of, it seems like a broader thing than just the code itself. And so I'm wondering but I haven't seen you talk about the audit, including consideration of the operational procedures or the key management solution that you have. So I'm just wondering if all of that is incorporated into the audit.
Look, I'll pass that one on to Ryan, I think.
I think that's a good question. Obviously, operational side of things is definitely important. But operational side, maybe Mark can jump in as well. I think from our point of view, it's easier to standardize compared to how the smart contract would look like. So we will typically do this internally. And from all the smart contracts that we have published so far, it has deep integration with Web2, and especially when it's related to gaming. So typically we find it difficult to have this scope for an external auditor. And I think internally, we have some level of confidence that we can do this. So when it comes to off-chain component, we would do it internally. Unless it's a component that's highly critical that's going to be used by the mass public, then we will consider to hire an auditor who's capable of doing both off-chain and on-chain. Wonder if that answers your question.
Yeah, I think so.
Thanks, Mark.
Thanks.
Yeah, wondering if Mark Baum, you have anything to add on on to you.
No, I didn't. I didn't have much to add because I think you're right. Like the infrastructure is, I guess, less changeable, and so there's a lot of work has gone into the underlying infrastructure and making that safe. And key management, we're going to talk about in a second. So yes, that's getting assessed, but it probably doesn't need to be assessed for each new smart contract because it's more static compared to the new contracts, if that makes sense. And I think, I mean, one could argue that a new smart contract might make an assumption about the infrastructure that isn't true. I think that's a good point and something that comes up through the threat modeling process is, like, are we doing something novel with this contract that means that we need to make different trust assumptions about the infrastructure?
Thanks.
Yep. Okay, David, over to you.
Yeah, thanks, guys. Very interesting talk. Thank you for that. Sorry if I missed it, but are all your contracts upgradable? And if not, what criteria do you use for the ones that shouldn't be?
Ooh. I would say, I think pretty much everything is upgradable. I think that there may be one or two that we've made the call where, like, there's, I don't know, it's pretty much it's not an interface, but maybe it's a function which just emits an event. And that's the only thing that, you know, the whole contract is one function. So anything beyond completely trivial ends up being upgradable simply because software can have bugs in it, obviously, but as well, invariably, you know, if we're deploying a system, this immutable zkVM, in 10 years' time, you know, how can we predict what features we will want to have in 10 years' time? I think that, you know, trying to get in ahead and say we understand every feature we're going to need to have for 10 years' time is impossible. So I think that's why, yeah.
Well, that makes sense to me. But there is this natural tension that occurs between features and security, right? And this is the heart of the matter. So, for example, when we did the Uniswap bridge assessment, there were bridges that, one in particular that, and I can't recall who it was off the top of my head, that relied quite heavily on non-upgradable contracts, specifically for security. Now, I can understand that in a gaming environment, that may be less appropriate because their features are not going to change presumably nearly as rapidly as yours are. But and I'm not making some case that all your contracts or any substantial portion of your contract should be upgradable. I was more just exploring how you feel about it.
Yeah. So, and it's a funny one, actually. That's really, so upgradable contracts, you've got the issue that even if not now, in 5 years' time, there might be a rug pull. And so even if say the upgrader, you need 7 people out of 11 to say, yes, we're going to do it. If you don't roll those keys ever, then, you know, a sufficiently sophisticated attacker could take them out one at a time and, you know, get to the point that they've got the threshold and then in 5 years upgrade the contract. So yeah, so it is a risk from that perspective. But then for a contract like a bridge, the issue you're going to have is that you have a lot of value in the bridge contract. So for an ERC20 bridge, invariably the endpoints of the bridge, say on Ethereum, will have all the money that you've got. So for instance, in our zkEVM architecture, you've got the ERC20 bridge, all the money that is on the zkEVM. So if there was $1 billion on that zkEVM, on the EVM in big inverted commas, it means it's actually sitting in that ERC20 bridge contract on Ethereum. And so if there was a bug in that code, you'd really like to fix it because otherwise you've got that $1 billion that's just sitting there. And so not being able to upgrade that contract to me seems like a huge issue. Yeah, so I think
the reason that I asked the question is that although I agree with everything you've just said, if I were to play devil's advocate on it, I would say the history of DAOs, particularly, and why they fail is because in the vast majority of cases, the community can't field enough representatives to vote or to hold keys or to do governance actions, etc. And the people involved, much less the software, the people involved in having permissions have deadlocked DAOs, and just through lack of action. And so, we rely quite heavily on these constructs, like you mentioned a 7 of 11 multisig, for example, and there are all these sort of social constructs that fundamentally resolve down to people. And that becomes your most vulnerable attack surface. And that could be through inaction, it could be through bribery, it could be through all kinds of other mechanisms, right? So it seems to me that this is, I'm trying to wrap my own head around whether this is a philosophically consistent problem that we're going to have in software, or whether we're going to find ways of designing to mitigate these problems over the course of time. And I haven't decided yet.
I'm not going to, I actually think the bigger problem, which I think Mark's going to talk about in the next section, in his huge talk about keys, is actually getting people to remember how to sign, how to vote. Because, I think that having a 7 of 11 works out really well if all 11 people at least know how to, or still have access to, they can still find their UB key or whatever it is. Anyway, look, I think we've had a few questions here, and so
I'll just finish off by saying that's an additional attack service. If you can tell them how to do it, you can influence the outcome.
Yeah.
Sorry for the long-winded discussion.
No, it's okay. And I did specifically ask for questions at that point, and I can see Sly's going on video, so he's roaring to go with a question, but Sly, can it wait until the end, and so that we can keep, all right, let's continue. So I'm going to hand the wheel over to Mark, and he's going to do his section.
Thanks. Before I jump into my section, I was just going to talk about the fact that I'm from a Web2 background as well. In fact, I'm old enough that I've been in software for quite a while. Most of us have been through this transition from like a waterfall software development lifecycle through to some kind of agile software development lifecycle. And what we've just presented to you looks like we're going back in time. It looks like it's you got to do this, and you got to do this, and you got to do this, and the security team's going to sign off, and then you can finally use your thing. And yeah, that's true. That's exactly what's happened. And that's sort of actually, to David's point, is because where we want to get to with blockchain technologies is that they are immutable, that that you have a very high level of assurance that you're deploying a thing that doesn't have a security issue. But fundamentally, they're less upgradable than a SaaS service. If there's a security bug in a SaaS service, you fix it. It takes 10 minutes to push a patch, and it's live, and there's sort of, you're able to do that before anyone even knows what's going on. But what we're doing is a bit more akin to a firmware update on a device. So by way of background, I used to work at Fitbit. I was in the security team there, and we had everyone wearing devices on their wrists. And when we found security issues in those, we had to push a firmware update. And we knew that it might take months to push a firmware update. And so that meant that the software assurance process we needed to go through before we pushed a firmware update was way more arduous than what we do for SaaS software, because the risk and the cost is much higher. So I think that's what you're seeing here as well. Actually, the same trade-off is going to happen as we talk about key management. Obviously, the most usable and most convenient process for key management is if everyone just has MetaMask on their computer and they can sign anything whenever they want to. There's no friction. It's fast, it's easy, you can test whatever you want, you get stuff done. That's obviously a little bit scary if your computer is a Windows XP machine without any antivirus, and you have access to upgrade proxy contracts to bridges. So what we have to do is we have to figure out the risk, and we have to balance that with the usability. And that's what I'm going to talk about through now is how we've gone about trying to make that balance. And the key is that there's no one size fits all approach, actually. We have to make a number of different approaches to key management depending on the specific use case. In each case, they have to balance the operational needs of the organization with the security requirements of the organization. Well, the way we've done that is we've looked at a bunch of different attributes for each of our use cases. And they're things like, how often do we have to use this key? Like, is it a one and done? Do we use it once a year? Or does it have to happen 15 times a second? Because that's going to really change the kinds of technology you use to manage the key. You know, if it's once ever, you might decide just to have that key written on a piece of paper that's stored in a safe somewhere. If you have to do it multiple times a second, that has to be online. You know, it has to be accessible by software. We also look at the impact of misuse. So, and there's two misuse categories I've got here, or two compromise categories, I should say. One is misuse, as in someone has the key and they're using it against us. The other is the key is gone, or someone's taken the key away from us. We can't access the key anymore. And they're important for different things. Misuse, the example might be someone has access to a key that can upgrade our contracts, means they can deploy malicious contracts. In the case of the bridge, that might literally mean that all of the money is gone from the chain. So that's a very high impact of misuse. Impact of unavailability is different. If we lost a key that we used for deploying new contracts, maybe it doesn't matter. Like if it's just gone and no one else has it, the impact is we can't deploy any new contracts that are verified by us on a Block Explorer, but we can make a new key, use that to deploy and verify it with the Block Explorer. So we have to think about those two different use cases differently. This is important for key durability. So one of the attributes we'll talk about with keys in a second is like, how certain am I that I won't lose this key? We'll talk about that in a minute. Another one is human versus machine use. We talked about the frequency. This is often tied to frequency, actually. But in some cases, we really want a human to be making decisions about whether a key is getting used. In other cases, there's no way to do it but to have it automated. And we've got to have to use different technologies depending on the two. I won't labor through all of these. You can read through them. There is one that's also important, though, which is urgent use. So we're going to talk about incident response, which is knowing when things have gone wrong. In fact, I should say, until now, we've really talked about preventing stuff from going wrong. But we've definitely taken the position that stuff will go wrong. And so regardless of how much prevention we've done, we have to be ready for when it does go wrong. And we'll talk about what we're going to do to find if something's gone wrong and how we're going to respond to that. But one of the things we might need to do if something's going wrong is pause a contract, upgrade a contract. And if we need to do that in a rush, we want to make sure that we can. And doing that's probably going to need keys. So we're going to have some kind of keys that have to be ready to be used on very short notice. This is really interesting because it's often very much in friction with, we only want it to be used if we're really sure that we want it to be used. So to put that another way, like if we want a key to be, if we want to be able to sign something all of the time within 15 minutes, it's probably not going to require all of our executives to sign it because it's going to be pretty hard to get all of them in 15 minutes. So that's going to be an interesting friction point you'll see as we go through here. I think you can jump onto the next slide for me there, Peter. And we use some guiding principles when we're designing our key management, what we've called paved roads. So the paved roads are, if you do it this way, you don't need to talk to us. If you've got this kind of key, use this kind of approach, you don't have to get any extra help from us. And I'll show you a flow chart that we've developed to help people determine which paved road to use. And you'll see one of the branches is come talk to us, because we know we can't capture every possible key use case in our thinking. But these are the principles. Wherever possible, prevent individuals from having access to plain text private key data. What does this mean in practice? It means using like a service like KMS in AWS or Cloud KMS in Google Cloud or an HSM device to do signing for you in a way where the keys can't be accessed by a human or exported by a human. It also means using a hardware device like a Ledger or a Trezor instead of using MetaMask or having it on a file on your computer. And we'll talk about why this is important. Actually, I'll talk about it now. We think this is important because whilst you can still compromise a KMS key, the impact of that is different to compromising a key on a disk. If you compromise a KMS key, you compromise the ability to sign with that key for as long as you have it compromised. If you compromise a key on disk, you have that key forever. It can't be changed. And so there's a different impact there. Let's say we had a service that co-signed transactions in our platform. If someone compromised the key to that and it was stored in KMS, they would have the ability to co-sign requests until we evicted them from the system, but they wouldn't have the key. If they compromise the key on disk, they would have that key forever, and the only way for us to evict them from the system would be to change the service that relies on that key to not rely on that key anymore. So that's one of the reasons we want to prevent plain text private key data. The other thing to know about plain text private key data is it's a virus. Once it's in someone's MetaMask, it's in a backup somewhere. Once it's in 1Password to share with a team member, that it's gone forever. These things just tend to spread, and so you can think of having them be non-exportable as just also a non-proliferation tool to prevent them from ending up in places you don't want them to, like in your source code repo, which we've seen so many compromises happen through inadvertent key commits. So that's the first one. Try and prevent plain text private key data. The second one is to try and make use of multi-party authorization wherever possible. In other words, do something like a multi-sig. This is a really important control because it means that the compromise of one key, of one access token, let's call it, for disambiguation, doesn't result in the compromise of the key. It also means there's a lot of insider risk in our industry. Individuals all of a sudden have really perverse incentives to become bad when they realize that their key is worth $1 billion. So we need to put some obstacles in the way of people being vulnerable to that temptation or being coerced into doing the wrong thing. So multi-party can help with that as well. If those two things aren't possible, like multi-party or exportable keys, you have to assume that the keys are going to get compromised at some place, and you need to tune your detection and response capability accordingly. And so if you know that with a key, that access to that key for 5 minutes would cause irrecoverable damage, then you better know that you can tell that that key is being misused in less than 5 minutes and do something about it. Otherwise, you're taking a significant risk there. We've got a principle as well that you should separate key use for asset storage and for transaction signing for non-transfer operations. So if you've got a contract that's meant to store a bunch of ERC20s, don't also use it to sign arbitrary transactions, because that's going to accidentally get you to sign something that results in loss of all those ERC20s at some stage in the future. Do you want to jump on the next slide for me, please? Thank you. This one is an interesting one, and I definitely welcome feedback on this, but we're taking the approach that there is risk in reusing multi-sigs for different purposes, but there's also risk in having lots of multi-sigs because there's a lot of admin overhead associated with multi-sigs. So the approach we're taking is that it's better to have fewer multi-sigs that are reused for multiple purposes than it is to have many multi-sigs and the associated admin overhead. So what do I mean by this? Let's say we might have 3 different multi-sigs in our environment, one for dealing with privileged operations, one for dealing with emergencies, one for carrying treasury. To the extent that those things have the same set of signers, we'll reuse a multi-sig rather than starting a new one. And what do I mean when I talk about admin overhead? Peter referred to this a second ago, but we have to make sure these signers can still sign. We have to make sure they're actually still able to do things. And that requires some sort of keep alive process where periodically people expect to receive a ping from a pre-agreed on channel that says, please go sign this thing to prove that you still have the ability to sign, to know up on some contract somewhere. We think this is really important. There's also other admin overhead, like in the case of our staff, if people change jobs. And so we need to know that when someone is leaving the company, we can reliably get them out of all the multi-sigs that they were a part of before they get a chance to make some friends and collude and steal money. Similarly, we might want to expire keys on multi-sigs periodically. So to Peter's point, North Korea doesn't have to compromise 3 of 5 on one day. They might do it over 3 years. They might compromise one person on 1 year. It doesn't help them, but they can sit and they've got that key. They can sit and wait. They might compromise another person a year later, and a third person a year after that. So it's a good idea for multi-sigs to be rotating those keys periodically and assuming compromise on a small number of multi-sig keys periodically. The one point we do stick to a multi-sigs though is we don't want to mix value storage multi-sigs and transaction signing multi-sigs as well, just to avoid that social engineering risk there. We'll talk a bit about in the last section as well about being ready to respond to incidents and how that will fit into things. So a couple of the paved roads that we came up with are listed here. Oh, actually, one last point from the last slide. I just wanted to point out that we have a principle of trying to use the same process in test nets as is in main nets. Now, you might tweak like the quorum on a multi-sig, for example, to make it simpler for people working in a test net to get changes made to reduce that friction that's there. But it's an important sort of control from the perspective of people being aware how the environment works. Like your test net should be as production-like as possible. So I think this helps with that. Some of the paved roads we've come up with. So we in our environment will have a privileged operation multi-sig. This is something like if you need to pause a contract or send a proxy contract and update to point to a different place, you would use this privileged operation multi-sig, and it's intended for very high risk changes to the chain, and it needs a sort of set of senior people to sign it. The break glass multi-sig, on the other hand, is intended for emergency use. So this is one where the SLA needs to be less than 15 minutes, which means you've got to be able to find enough people to hit quorum who are on call at any point in time, which means it has a lower quorum and a larger number of people involved. But it can also only do things which are short-term damaging, like pause something on a chain as opposed to upgrade something on the chain. We've got deployment keys, used for deploying contracts, and programmatic wallets. A service that's running has to be able to distribute funds to someone. That will have its own kind of wallet and manage keys in its own sort of way. John, jump to the next slide for me, Peter. This is probably going to be hard to read, I'm sorry, but it was more just the idea I wanted to talk about here, which is that you should, as an engineer in our company, be able to read through this flow diagram and see your use case here and understand which paved road to go and use. So like, are you deploying something? Yes. Okay, well then use the deployment key, end of flow chart. But you'll see towards the end there's a talk to security one, which is like, we don't think you're going to fit anything into our use cases. Come and talk to us. Next slide, please. So to jump into some detail on one of these, I wanted to give you an example of the paved road for our deployment keys or deployment EOA. This is what we use to deploy all the smart contracts on the CKAVM. We use one of them. We do that because we want to make it clear in the Block Explorer that this was provided by Immutable. You can trust this contract to the extent you trust Immutable. We also want to actually use it as a gate. So to talk more about that waterfall style, the fact that we control this key means that we can come to you and say, did you audit this contract? Is it a high risk contract? Have you done a competition on it before we give you the key to go and deploy it? For us, this is actually stored on a hardware device that's physically secured. That gives us, even though it's an individual key, it gives us some multi-party authorization in that the person who can physically access the device is different from the person who can unlock the device to use it. And the key material is backed up and sharded in a way that we know guarantees durability because we don't want to lose this key. But that backup process is done in a way that no one person can get access to the raw key. And when I talk at the beginning about the sort of attributes for each of the things, this is how we think about the paved road attributes for this deployment key. So this should be used pretty infrequently. It might be used a lot when we first stand up a chain, but after that, deploying a new contract should be a relatively infrequent operation. So it doesn't matter that there's a bit of friction associated with physically being somewhere to use this key. It's pretty resilient against misuse. We've got hardware involved, there's secure storage of the hardware. It's durable because of that key backup process. It's not great for machine use. You need a human to physically plug a thing in, but that's okay. Deployment's infrequent. We shouldn't need to urgently use this, the exception being in a big emergency when we want to push a new version of a contract and then do the upgrade, but with a process in place for that. And this isn't one that we can use remotely. Another thing we looked at is remote use, whether we need people to access this remotely. This one, you have to physically be somewhere. So yeah. Do you want to jump to the next slide, Peter? Another example would be our privileged operation multi-sig. So examples for this would be, as I say, upgrading a proxy destination or changing bucket limits in our bridge contract. This is these are high impact operations. This is currently a 3 or 5, but obviously we can upgrade that as the risk of the chain changes. And each signer on this has a hardware wallet that has to show up to the multi-sig to sign their bit of it. If you look at the next slide on this in terms of its attributes, it brings a lot of friction. Getting a hold of those signers is meant to be something that's hard, but given the impact of this and the frequency of it, that's a reasonable trade-off to make. It's very resilient because multi-sigs, but it's got multi-party. We don't actually have the keys; they're on chain. It allows for revocation of signers and appointment of new signers. I think that's all I want to talk about on that one. But for each of our paved roads, we have a page like that. The engineers here can decide, should I use this thing? And they can also understand the attributes of it, which hopefully, one of the things we're trying to face into there is, we know this adds friction for engineering users. We want them to understand why that's necessary and to, I guess, support the decision to have that friction there. Well, we saw the puppy, so it's made the talk for me. I want to talk about incident response planning as well. So we talked about needing to think about prevention and response. No matter what we do on prevention, something's going to happen. Actually, a big part of my career, I was a security consultant and actually worked in incident response. And I used to ask the question like, well, how would you know if you had an incident? And people would be like, well, we'd know, like something would break. And we always just say, well, you wouldn't know. There's no incentive for the attacker to be noisy. They're going to be as quiet as they can. Like, unless you're looking for it, you're not going to see it. Or you'll know, but by the time you know, they've been there for ages and they've already stolen all the money. And so that's what we need to do here as well, is we need to make sure that we're thinking about, from that threat model, what it's going to look like if someone is trying to attack our services, and to be ready to respond to that. So that looks like having specific monitoring playbooks. And a monitoring playbook is a combination of like, we're looking for this thing, and this is how we triage to determine if it's a problem or not. That flows into an incident, which then has a response playbook. And in a response playbook, there are 3 steps. And I think maybe you could just jump to the next slide for me, Peter. Just skipping back to monitoring for a second. Some examples of monitoring things might be looking at looking at a contract and seeing if someone added a new key to a new role. So that privileged operation multi-sig, like, we know all of our contracts will allow that to do certain things, but if we saw another contract being granted those roles, that would be something we'd want to investigate. It may be that through triage we see, oh yeah, this is a legitimate change. This person in this team is rotating something. It's fine. But if we couldn't explain it internally, we would want to turn that into an incident, very quickly figure out what was going on. There's a bunch of other examples of things here that you could monitor. Seems to be a pretty active area of development in Web3 space at the moment, is how to do monitoring effectively. And a few interesting products coming out in this space. The next slide we'll talk about response planning. You saw there were 3 steps there. So there's investigation, containment, and recovery. And you can think about investigation being like, in terms of planning for investigation, you can think about, like, how would I know what was happening? Like, which tools I'm going to need, what data am I going to need? If this thing has happened, how would I be able to determine more details about it? With the goal of being able to contain it. So what information am I going to need in order to stop this thing from getting worse? Containment is really the process of like, okay, well, I've lost this much money, but how do I stop myself from losing more for now? Or the chain's in a state where people can't trust it. How do I stop it from being in that state? And that's distinct from recovery, which is getting everything back to normal. So in an incident, your first priority is always containment, stop the thing from getting worse, and then you work on getting it back to how it's intended to be after the fact. And investigation is the underlying process that you use to get the data you need to do those 2 things. But for response, you have to plan ahead of these things. So in the case of a bridge compromise, like, we need to know, how would we know that this is happening, but also, like, where are we going to go to mine the data we need to determine which accounts are evil in the system, or which central exchanges we want to go talk to ask them to freeze funds. And if we haven't pre-planned to have that data available, it could cost time in the response process. Next slide, please, Peter. That was what I wanted to say on key management, detection response. Just a brief word on bug bounties and responsible disclosure. So we talked before about doing audits and competitions, and those were sort of pre-release security diligence activities. But obviously, once you release this thing out into the world, you learn that all the assumptions you made about the environment were incorrect, or new techniques get developed against the tools that we're using. And that's where you need to have a bug bounty and/or a responsible disclosure process. These are probably familiar to you all, but this is just where you basically advertise to folks that, like, we're willing, we're very receptive to any issues you find, please tell us. And your goal is to set up some sort of incentive for folks who do find issues to tell you about them rather than use them against you. There are a few companies out there that run these sorts of things, like Immutify. They can often help you with triage on the bugs too. Not always, as Ryan says. But they can definitely help you define the scope and publicize it, find the right kinds of researchers to look at your system, to manage payments, which can be a hassle, to KYC, that kind of thing. This is a really important part of the step, because the only thing you know when you release something to the world is that you've made some assumptions that are going to be untrue. And this is a great way to shake that out over time and keep that focus on your ecosystem post-launch. And that's all I wanted to say on that. Over to you, Peter.
Thank you. Yes, and I thought that the next section deserved a AI-generated image of Ethereum and blockchain in after, post-apocalyptic, so after the bomb's gone off. And yeah, so being attacked is not good. It's are there any, let's do questions. So James, I can see you've got a question. Please go ahead.
Yeah, thank you. That was a really great presentation. Thank you from Mark and Ryan. I was just thinking back to a comment made previously about the social layer being one of the biggest attack surfaces for multi-sigs, and your mindset that you've instilled into us, Mark, being that, the attack is already here. Now, in the incident response plan, how do we ensure, for example, that the second signatory isn't just following the command of the first signatory? For example, if they were compromised, we've talked about instances where there's bribes, instances where the person could be under threat. Like, I've just been reading about multi-sigs in general, and do we have like a duress keyword or something that would be able to distinguish, hey, I don't actually want to authorize this. For example, the attackers purposely scaled up an incident. What's the thought around that social layer and our response to it?
Yeah, it's an awesome question. And it's really about planning as well. So it's about having pre-agreed protocols for how you're going to communicate an incident, so that people can tell in an incident if one of these things is awry. It's going to be tricky in the case of, let's take the break glass multi-sig, where we're really optimizing for speed. There's a bit of risk there. Like, there's less people involved, and so collusion's possible. But in those cases, you're trying to limit the damage someone could do with that. In the case of that key, maybe they can pause the chain, which is a bad day from a PR perspective, but probably doesn't cause as much harm as the bridge being emptied, for example. But yeah, definitely the key there is having a plan for how comms happen and sticking to that plan. It's worth mentioning that one of the attack cases we've considered is that the comms platform that we use for those communications is also compromised. And that, you sort of get into scary problems there, where you're like, well, how would we know if that was the case, and where would we switch to, and that sort of thing. Definitely in previous roles, we've maintained a parallel communications infrastructure for use during incidents. Maybe that's something we'll have to consider here in the future.
Great answer. Thank you very much.
Wow. And what's our magic word, Mark, on this public YouTube video?
Yeah, exactly.
All right. Sly, fire away with your question.
Yeah, I was just kind of following up on David's concerns. I mean, one of the points of blockchain is that you can have immutable contracts, and that's a selling point. So being able to modify a contract itself becomes an attack vector. And a lot of the talk is actually, maybe it's a misleading branding or something, but maybe it's actually talking about how to change contracts and all the security considerations. But I think this was asked before, but I mean, any further thoughts on actually when and how to use immutable contracts? I was thinking maybe like time frame could be relevant. Like, if you've got a long-running contract that's actually it's actually just long-running software, right? It's not a contract in the normal sense. It runs a bridge or something, it may operate forever, there's no end date. So there's a risk of bugs is high, so therefore you need a way to change it. But like you can have short-term contracts as well, like an escrow agreement between two parties or something that kind of just starts, runs, and then ends in a fairly short time frame. Or maybe it's like maybe your bridge actually deploys out contracts for actual operations or something like that. Would those then be effectively immutable? Like, is there some? Did you actually use immutable contracts anywhere, or? As I said, I think this is answered before, but I'm just, yeah, can you, is that definitely, you don't use immutable contracts at all?
Yeah, go ahead, Mark.
I was just going to say, I'm going to let it go through Peter, because we definitely have some contracts that aren't changeable. But given the sort of novelty of the ecosystem and where we're at and how we're learning, I think for now the preference is to have things that are upgradable so that we can deal with the things that come our way. I completely agree with other folks who've mentioned that immutability is in some cases a really nice attribute. It enables trust. It enables, like, you can make certain guarantees about things.
Yeah, I think what Peter mentioned was like having a simple function that is still going to be there forever, and you don't make it immutable because it's simple. I'm talking about, would it make sense to take portions of your contract that are like, say you're running a game, for example, you might have the game might be broken into rounds. So for round one, you deploy out a contract and you don't change that. If your control contract, you might change, but you know, once the game's started, it doesn't change.
And which was funny though, because I was going to say that in that context, you often see a different type of upgrade. And so what that is if you've got a control contract and various other utility contracts that are doing things, often they don't hold much data and they don't hold value. And if they don't hold much data and any value, then you could just switch to a completely different contract that has, the new capability. So you can have a different round one. But I understand what you're saying though, and I think it really does come down to the use case. But because we're developing a platform at Immutable, so it's all about a platform. So we're developing, this base layer that everyone's putting their stuff on top of. We're, I think, more likely to have extremely long-running technologies that we do need to worry about, whereas potentially games might, have some contract that they're going to deploy that is that maybe can be changed or upgraded. But again, you can imagine if you've got a game, you're hoping that it's going to be like, say, I don't know, Minecraft or something like that, where, a decade later, people are still playing it and you're still bringing money in.
Yeah, but as I'm saying, if it's a long running one, then it's a software that needs to change, right? If it's over a long time. But if, for example, it was not Minecraft, but it was something that ran in rounds, or something where or like this is an escrow contract. I want to buy a shipment of grain off you, put the money in escrow. When that shipment arrives, you get the money out. That contract is ended. Like it has a finite life.
I think, so I think for supply chain sort of contracts, which is obviously we're working on, but that probably makes sense where the whole thing's is a template contract. It's the same. And so, for instance, our ERC20s, if you bridge money across from Ethereum to the zkVM, you get a contract deployed that's an ERC20 and it auto deploys, and it's just a template contract. And so if you had some, say, supply chain agreement for, delivery of grain or whatever, you can imagine that's going to be a template contract anyway, and it's not going to be a one-off. So, and it's also, as you say, limited lifespan of, say, 3 months or something. So I think that's a different type of thing.
Yeah, that's all. I just trying to think. What are the driving? In your case, it was if it's not going to change. In this case, I think another case is if it's going to have a lot, because then you're protected against what if there's a bug in it? Well, you don't care because it ended 12 months ago, and it's
it just doesn't matter anymore. Yeah.
Yeah. Cool. That's all.
Yeah. All right, let's get into dealing with an attack. So you're going to find out about an attack by a few different mechanisms. So the first one, or the third one that I've got in my list, but is what Mark said, is you've got some tools and you detect that something's happening. Or maybe no one's exploiting the vulnerability, but you detect it yourself and you realize there's a vulnerability in your deployed code. Which in some ways would be the ideal way of finding out about an attack, is finding out that no one's attacking this glaring hole in your code. Another one is security researchers. So invariably, these are PhD students. And what they want to do is they want to find a vulnerability in your code. They want to report the vulnerability to you. They want you to say, yes, you wise person, you have found a bug in our code. And then they want to write an academic paper on it. So they do not want you to publish it with a little bit of acknowledgement. They need to be able to coordinate with you the publication of the vulnerability information so that they can say, hey, I came up with this. I am the person who gets to print the academic paper on this. And, so that it is really about academic publication for a lot of security researchers. Not all, though. And certainly if you find an issue with our code, so we're going to launch a bug bounty program, but we're also got security@immutable.com. The other way is, of course, that you've got an attacker who's actively exploiting your contracts. And so if that happens, you can do what's called white hatting your own contracts. So maybe the contracts hold value. And so what you can do is, using a private mempool and not the public mempool, you could essentially run the attack but move the money into a wallet that we control ourselves. Curiously, in a really recent attack on Curve, the attacker used the public. So they did this really complicated thing where they've worked out this attack, obviously spent, a huge amount of time doing this, got tools to do it. And then they put their attack transaction in the public mempool and were front run. So yes, if you're going to black hat or white hat, don't use the public mempool, because chances are someone will front run you, and there are bots that will automatically front run. So so use a private mempool to submit your transactions. And the other thing is that, that we've got is to use that smart contract registry that we've developed to really find out and, understand what's going on and trying to draw the diagram of how the attack is actually happening. And so that's something to have. So something that you've really got to be careful of is not communicating information publicly. And so, look, I was involved in the OpenSSL Heartbleed attack, which is now probably about 15 years ago, but that essentially meant every SSL server or TLS server on the internet was potentially vulnerable. And so there were huge numbers of people who were potentially vulnerable to attack, and there was no patch. And so the 2 or 3 months worth of time required to develop a patch for that was all done in secret. And so similarly, in this situation where you've got people using your code, you need to be making sure that you're not publicly discussing it, especially if the vulnerability isn't out there in the open and isn't being exploited. So if you've got a security researcher, you do not want them to be doing a PR, a pull request, on your public repo. You don't want them to be submitting an issue saying, hi, do you realize there's a vulnerability in your code? This is how to exploit it. People have done this in the blockchain industry. And then tens, hundreds of millions of dollars goes walking away because someone has not done the communication right. So once you've found out that you've got an issue, if you're going to have external audits, communicate with your auditors. And so have a communication mechanism that's available and communicate with them, because if they've done an audit, they're going to have reputational damage if someone's found a bug that they didn't find. And so they're going to be busy trying to prove to themselves and to you and to everyone else at the appropriate moment that the bug was in some code that they didn't audit. And so they're going to be really busy trying to do that. Because otherwise it looks really bad. So you need to clone your public repo and have it as, have a private repo and build and fix and test out the issue in that private repo, so away from public view. And then you need to deploy from the public repo, from the private repo, should I say. So if your systems are such that you can only deploy it from your public repo, then this is going to be a real problem. So you need to be able to work out a way that you can deploy your contracts from a private repo, because otherwise you will need to signal to the world that there's a problem. And we've seen that there was an attack a few months ago where the team did everything in the private repo. Then they did the PR, approved the PR, and then deployed in the public repo. So in the 10 minutes or so that it took for them to push PR, do the pull request, approve the pull request, and deploy, the attacker had realized what was going on, obviously had their own monitoring tools happening, and they exploited the contract. So yeah, definitely need to be able to do everything in the private repo. So assuming you've got an external person who's reported it, you need to coordinate with them, as I said, and you need to write up a root cause analysis, which carefully goes through what's happened, how it happened, what you've done to remediate, and was any money taken. So are there any questions about how to do development in times of attack? Okay. Another thing that we've got is required features for contracts. And so we require anything but the most trivial contract to have role-based access control. So anything that's got, say, administrative functions, we need to be able to separate out the roles and also have multiple accounts for the one role as well. And you need to be able to say, create new roles in the future. So you might upgrade the code. And if the original contract doesn't have role-based access control, but suddenly you've got some new capabilities that require control, some control functions, then it's going to be really complicated. So it's better to have role-based access control, even if you've only really got one role initially, which could be covered by an owner, and then you then you can add more later. Pausing and unpausing are features that most or many contracts need, and so we have a pauser role and an unpauser role. So I think both Ryan and Mark have gone through this, but to double down on it, pausing is annoying. It will probably cause you reputational damage, but having a low threshold so that your people who are it doesn't matter which day of the week, what time of day, which day of the year it is, the bridge or the system can be paused is really important. So having that threshold maybe lower than you might, maybe it's say 2 or 5 rather than 3 or 5. Unpause though, could allow, once you've paused the bridge because you realize you're under attack, if the attacker can unpause the bridge, then that's a really big issue. So that unpauser needs to have a much higher threshold than a pauser does. So worth thinking about. And obviously upgrade. So we assume that upgrade is going to be needed. And so the who can upgrade is going to be similar to who can click unpause, that same threshold level. So some final thoughts, the attacks are evolving all the time. And, the process that we've outlined today and what we do is going to evolve with it too. And, as we gain more experience, see more attacks, things will change. But look, having having a process is actually a really good sign and does make us more resilient to attack. And the number of Web3 companies that you'll find just do not have processes, even ones that you perceive to be quite mature, that just do not have any process around attack or around smart contract development. So I think having a process is going to make us really resilient. Having an incident response plan means that when an incident happens, we actually know what we're going to do. And so we've got a plan in place, so we should be able to successfully mitigate attacks. And so that's, I think some, key thoughts there. And I don't know, say, Ryan, do you have any other thoughts you'd like to add as a final thought?
No, not really. I think, Peter, you covered most of the stuff.
Yeah, and Mark, any final thoughts from you?
No, just talking about incident response plans make you go faster, and in our world, fast is everything.
Yeah, exactly. Yes, you've got 10 minutes or less.
Yeah.
Yeah. All right. And so the merch store is open. So you can go from the YouTube channel to the merch store, or you can just go directly. Interesting t-shirts for you to consider buying. We have some future talks coming up. And so in about 2 weeks, we've got Philip Zettner, and he's going to talk about why he thinks bridge aggregation is actually a really good idea. Christian is going to talk about Solidity development using Forge. Clemens is going to talk about Web3 and AI and his thoughts on it. And then in September, so that's actually only just over a month away, I'm going to talk about the Passport wallet and the Immutable ZK EVM. So I'm going to talk about the architecture of the overall system and then make everyone feel comfortable that our easy to use contract wallet is also super secure and is actually a really good one, especially for Web3 gaming. If you're here today and you want to watch this again, there's a YouTube channel. If you're watching YouTube and you want to come along and ask tricky questions, then come along to the meetup. There is a Slack workspace, and for talks that involve source code, there is a repo with example code. And that is enough talking. Does anyone have any final questions that they'd like to send our way?
I do, Peter.
Oh, yeah. Go ahead.
Great to see you again. Sorry, I haven't been joining the talks, and yeah. So my question, Peter, was about the multi-chain, the cross-chain, blockchain communications. Having worked at Crypto.com, which is recently, we had the IBC, the Inter-Blockchain Communications project, which was really interesting. So I was thinking of maybe saving this question for the blockchain aggregation. I just noticed there will be an episode entirely on this. But yeah, simply the question was about how does the product roadmap look? Is this part of the future plans? But I kind of got my answer in the last slides. But yeah, whether there's any value in this, that they sometimes separate these into cross-chain or multi-chain, and there are issues with regulators, as you know, and as someone who keeps an eye on layer 2 of Bitcoin, for example, this is of really great interest to me, and having been involved with Crypto.com as well, the rootstock, EVM compatible contracts and all this. But yeah, I don't want to grow my question. It was simply about the roadmap and relevance of this.
Oh yeah. So so roadmap for the meetup or roadmap for Immutable?
Immutable, actually both, I would say.
Yeah, all right, sure. Well, I've outlined some talks that are coming up, and there is one other talk. I've come up with an innovation for security of ERC20 bridges, which I'm going to do a talk on at some point probably in October. We'll do the passport one first. But it's actually something that I think is a really novel innovation, which I'm keen to see what other people think. And I think it actually it would have mitigated the Nomad hack, or stopped the Nomad hack, stopped the Axie Infinity hack, and in fact, stopped most of the ones on the Rect leaderboard from actually really happening. So I think, you know, something that could potentially stop $2 billion worth of attacks, probably worthwhile having a chat about. But anyway, that'll probably be in October.
Awesome.
Yeah.
And those attacks are some of them are really sophisticated, but it's some preventative measures, as you mentioned, could have prevented a lot of them as well. Yeah.
Yeah, for sure. And so for the Immutables roadmap, look, I think we're in the midst of launching the Immutable ZK EVM system. We've got several games that are right, you know, in the midst of getting their development going. With the games, there's been a whole stack of game signing and game studios. So it's not just single games, but whole game studio signing. And so I reckon that, you know, we're going to have the system launched in the coming months. We're going to have you know, games coming on. And I think that the system will be hardened. We're going to have some big game studios that are going to say, hey, we need an app chain all to ourselves. And then we're going to be worried, you know, having a multi-chain architecture. And I think that, you know, we're going to see potentially a move from the whole way of having these games where, you know, you say you've got all these in-game assets, $1 million worth of in-game assets, but at the end of the day, you know, someone can just delete your account and you don't really have true ownership. And I think that there will be a big move to this sort of Web3 gaming. And I'm really, you know, really proud that I'm working at Immutable to make this happen. And I think that we're doing an awesome job, and that I think that we are really well positioned to, you know, do great things. And so, I'm pumped to see how everything turns out as well. So, I mean, but I think getting the multi-chain future of Web3 gaming happening and creating an awesome Web3 gaming platform is really what we're about and where we're headed over the next 12 months and beyond.
Yes, awesome stuff, Dan. Thank you. This is really of interest to me as well, how things in the end tie together. Really cool. All right, thanks.
All right. Thank you, everyone. Have a great week. Bye-bye.